In the black water of a Jurassic Sea, a predator the size of a bus is hunting in complete silence. It has eyes the size of footballs, the largest of any animal known to science, and a fossil described in 2025 reveals how it hushed the sound of its own body as it swam. And it is only the beginning. The same deep past holds a whale with teeth longer than a human forearm, a sea lizard that hunted other sea lizards, and a reptile that may have rivaled a blue whale. Every one of them was real. Everyone sits in a museum today. What follows is a dive through that deep past, and the deeper it runs, the older and stranger its rulers become. None of these animals shared an ocean, or even an age. Arranging them as one dive is a device, a way to fall through deep time by falling through water. The surface belongs to the recent past, the bottom belongs to seas that were gone before the first dinosaur, and the descent starts at the top, in warm, sunlit water. For most of its scientific life, the largest shark that ever lived was known from almost nothing but its teeth. Otodus Megalodon left behind serrated blades the size of a grown adult's hand, scattered through rock from roughly 20 to 3.5 million years ago, and little else. No complete skeleton. A shark's body is mostly cartilage, and cartilage rarely survives. Then in 2022, Jack Cooper and a team at Swansea University found a column of fossilized vertebrae complete enough to rebuild the whole animal in 3 dimensions. Their model, published in Science Advances, put an adult near 16 meters, fast enough to outcruise any shark alive, able to swallow prey the size of a killer whale in a handful of bites. That same year, a second team read the chemistry locked in Megalodon's teeth. Nitrogen accumulates in a hunter's body with every rung it climbs on the food chain, and the readings in the enamel sat higher than anything in the ocean today, the mark of a carnivore that fed on other large carnivores. A follow-up in 2024 added caution, arguing that part of that signal may track the animal's sheer size rather than its rank. The debate stays open. The shape of the thing does not. This was a predator that treated whales as food, and it did not have those whales to itself. In the coastal desert of southern Peru, erosion has been exposing the bones of a hunter built on the opposite plan. Its skull alone runs about 3 meters. Set into both jaws are teeth longer than 36 centimeters, the largest biting teeth known from any creature that has ever lived, tusks aside. It was named Livyatan Melville in 2010, after the biblical Leviathan and after the author of Moby Dick. Livyatan was a sperm whale, and nothing like the gentle one that carries the name now. The modern sperm whale dives deep and takes squid by suction, its upper jaw toothless. Livyatan reversed every part of that. Heavy enamel-coated teeth, top and bottom, a body between about 13 and 18 meters, and, researchers infer, a habit of seizing large prey head-on, most likely other whales. So for a long stretch of the Miocene, one sea carried 2 rulers of nearly equal size, a colossal shark and a colossal raptorial whale, working the same water and, in all likelihood, each other. Sink below them, and the mammals disappear. 66 million years ago, in the last act of the Cretaceous, a bed of Moroccan phosphate preserved something grim. Fossil after fossil emerged half-dissolved, the bone eaten back as if by acid. Large predatory fish, a sea turtle, the half-meter skull of a plesiosaur, pieces of at least 3 separate species of mosasaur, the giant marine lizards that ruled those waters. Something had swallowed all of them, broken them down, and left the scraps. In 2022, Nick Longrich and colleagues named the likely killer, Thalassotitan atrox. Its skull reached about 1.5 meters on a body near 9, the length of a killer whale carrying a head almost twice as long. Its own teeth seal the case, chipped, broken, and ground down flat in a pattern that catching fish never produces, but crushing bone does. Thalassotitan hunted the other hunters of its sea and left a graveyard of them in the rock. Everything so far belongs to the last 66 million years, the shallow end of deep time. So how much stranger does the ocean become once the age of dinosaurs still lies ahead of it rather than behind? Descend into the Jurassic, and the answer opens with a lesson in how easily a monster gets inflated. In 2009, 2 enormous skeletons came out of the frozen cliffs of Svalbard in the Norwegian Arctic, from a site so rich it has yielded more than 60 marine reptiles. A television documentary christened The Larger Animal Predator X and announced a 15-meter killer with a bite 4 times stronger than a Tyrannosaurus. The claim raced around the world. Then the scientists finished the work. When Espen Knutsen, Patrick Druckenmiller, and Jorn Hurum formally described the animal in 2012 and named it Plesiosaurus funke, their paper carried no bite force figure at all because the skull was far too incomplete to support one. They recast it. Not the largest sea predator ever, but one of the largest pliosaurs yet found, a short-necked, four-flippered pursuit hunter with a lower jaw around 2 to 2.5 meters, and they warned plainly against the headlines their own fossil had inspired. The real Pliosaurus funky was still a formidable hunter of other marine reptiles. It simply was not the record-breaker television had sold. In this field, the distance between the story and the specimen is often the most useful measurement in the room. Deeper into that same Jurassic Ocean moved the silent hunter from the start of this dive. Temnodontosaurus was a giant ichthyosaur over 10 meters long, and for 200 years it was known only from bone. Then a single fossilized front flipper surfaced in the dark shale of southern Germany, and in 2025 an international team led by Johan Lindgren, working with the ichthyosaur specialist Dean Lomax, published what it held: soft tissue intact, the first ever recovered from a large ichthyosaur. The flipper carried a serrated, wing-like rear edge stiffened by tiny rods of cartilage no one had ever documented, structures the team had to name from scratch. Writing in Nature, they concluded it worked like the fringed feathers on an owl's wing, smoothing the flow of water and muffling the sound the animal made as it swam. Set that against those football-sized eyes, built to gather the faintest light, and the picture sharpens. A predator shaped to move through dim or deep water and strike before anything heard it. It hunted, in other words, by vanishing. Cross into the Triassic, a little over 200 million years ago, and the reptiles reach a scale that still strains belief. In 2016, a fossil collector named Paul de la Salle found a strange slab of giant jawbone on a Somerset beach. A few years later, walking the same coast, an 11-year-old named Ruby Reynolds turned up a second piece of the same kind of bone. Together they belonged to a new animal, described in 2024 and named Ichthyotitan severnensis. The more complete jaw fragment, on its own, ran over 2 meters. Scaled against its relatives, the whole reptile is estimated near 25 meters, close to the length of a blue whale, which would make it the largest marine reptile ever formally described. The team is careful with that figure. It rests on jawbones, not a skeleton, so the length is an informed estimate rather than a measured fact, and the microscopic structure of the bone suggests the animal was still growing when it died. Whatever its true size, it was among the last of the giant ichthyosaurs, ruling right up to the extinction that closed the Triassic and erased them. And the strangest thing about these ocean giants is not how large they became. It is how quickly their lineage got there. Drop back another 40 million years to the middle Triassic of what is now Nevada, and the sea already held a 17-meter ichthyosaur with a skull 2 meters long, named Symbospondylus youngorum, and described in the journal Science in 2021. It is the earliest giant animal known from anywhere on Earth, in the water or on land. What stopped the team led by Martin Sander was the clock. Ichthyosaurs had entered the ocean only a few million years earlier, in the wreckage of the worst mass extinction the planet has endured. Reaching this size took them roughly 3 million years. Whales, following a broadly similar route far later, needed something closer to 45. The ocean, it turns out, can build a Leviathan with startling speed, as long as the food web can feed one. One level remains, and it is the oldest and darkest of all. Sink past the reptiles entirely, past the first dinosaurs down to the Devonian, more than 350 million years ago, before a single tree stood on land. The ruler here is not a shark, a whale, or a reptile. It is a fish sealed in bony armor, and it has no teeth. Instead, the front of its jaws formed 2 long blades of bone that sheared against each other and sharpened themselves with every strike, driven by a linkage that could snap the mouth open and shut in a fraction of a second and pull in water and prey together. Its name is Dunkleosteus terrelli, and for a century it was reconstructed as a shark-shaped monster up to 10 meters long. Then in 2023, Russell Engelman built a new method for estimating the length of these armored fish, calibrated against thousands of living and fossil species, and published it in the journal Diversity. Measured that way, the largest known Dunkleosteus comes out near 4 meters, a typical adult closer to 3.5, shorter than the legend, and no gentler for it. Engelman describes an animal shaped like a wrecking ball, short and immensely thick, carrying a mouth wider than a great white's on a body about as heavy. It stands as a reminder that the deep past is never quite settled. It gets revised, carefully, as the tools sharpen. That is The Descent, a Miocene shark that fed on whales, down through seagoing lizards and record-breaking reptiles, to an armored fish older than the forests. 8 animals, no 2 of which ever shared an ocean, each one tied to a real specimen and a paper anyone can open. And back at the top of the dive, in the dark Jurassic water where this began, the silent hunter is still there, eyes the size of footballs open in the gloom, its fins smoothing the water until it makes no sound at all. The unsettling thing about the ocean's monsters was never that someone imagined them. It is that every one of them was real, and the fossil record only runs deeper from here. Till the next find, this is Bone Atlas.